Calculating electrical box fill is a crucial aspect of residential wiring to ensure safety and code compliance. The first step is determining the correct conductor count within the box. All conductors within the box are counted, including ground wires. The switch itself does not count as a conductor in the calculation. In the example provided, there are three instances of wiring. Firstly, a 40-2 cable enters the box as the supply. This cable contains three conductors, which are the black, white, and ground wires. Secondly, a 40-3 cable exits as part of the three-way circuit. This cable contains four conductors, which are the black, red, white, and ground wires. Thirdly, another 40-2 cable exits to feed another branch. This cable, again, contains three conductors. There are also two internal cable clamps utilized within the box. These clamps are counted as two conductors. With the conductors accounted for from the cabling, two cable clamps, and knowing the switch itself doesn't count, the total is 13 conductors in the box. With the conductor count established, the next step is calculating the required cubic inches of the electrical box. This calculation is based on the American wire gauge, or AUG, size of the conductors. For 14 AWG conductors, each conductor is counted as 2 cubic inches. In the example with 14 AWG conductors, the calculation is 13 conductors multiplied by 2 cubic inches per conductor, resulting in 26 cubic inches. Thus, the electrical box must have a minimum volume of 26 cubic inches to accommodate these conductors. When there are mixed wire sizes within the box, the cubic inch calculation is based on each individual wire size. Using the provided example, only the supply is a 12-2 cable, the rest are 14 AWG. The 12-2 supply cable has three conductors. Since they're 12 AWG, each conductor counts as 2.25 cubic inches according to the National Electrical Code, or NEC. 3 conductors multiplied by 2.25 cubic inches per conductor equals 6.75 cubic inches for the supply cable. The 40-3 cable has 4 conductors. These count as 2 cubic inches each. So, 4 conductors multiplied by 2 cubic inches per conductor equals 8 cubic inches. The other 40-2 cable has 3 conductors. These count as 2 cubic inches each. 3 conductors multiplied by 2 cubic inches per conductor equals 6 cubic inches. The 2 cable clamps are counted as 2 14 AWG conductors, which count as 2 cubic inches each, totaling 4 cubic inches. Adding all these values together results in 24.75 cubic inches. Rounding up to the nearest quarter inch, the box will require 24.75 cubic inches. In addition to the conductors and cable clamps, any other devices or wires in the box must also be counted towards the total cubic inches. This includes devices such as receptacles as well as ground wires, if they are connected to anything other than the ground screw. It's important to consult the National Electrical Code, specifically Article 314.16, for detailed box fill calculations and requirements. The actual size of the electrical box must be sufficient to accommodate all conductors and devices without overcrowding. Overcrowding can lead to overheating and potential fire hazards. Always choose an electrical box that meets or exceeds the calculated cubic inch requirement. This will ensure a safe and code-compliant electrical installation. To summarize the key steps. Firstly, accurately count all conductors within the box, including grounds. Secondly, determine the cubic inch value for each conductor based on its AWG size. Thirdly, calculate the total cubic inch requirement for the box by adding up the individual conductor values, device fill, and any other applicable volume allowances. Fourthly, select an electrical box that meets or exceeds the calculated cubic inch requirement. Fifthly, ensure that the installation is performed in accordance with all applicable electrical codes and regulations. To elaborate on conductor counting, it is critical to identify each conductor that contributes to box fill. This includes all current carrying conductors, neutral conductors, and equipment grounding conductors. For example, If a cable enters the box and continues to another device without any splices or terminations within the box, the conductors in that cable are counted only once. However, if the conductors are spliced or terminated within the box, each conductor involved in the splice or termination is counted. In the case of equipment grounding conductors, the NEC permits all equipment grounding conductors entering the box to be counted as a single conductor, provided they are connected to a common termination point within the box. However, if any of the equipment grounding conductors are isolated or insulated from the common termination point, they must be counted individually. For example, if there are 314 AWG equipment grounding conductors entering the box and they are all connected to a ground screw, they are counted as a single conductor, or 2 cubic inches. However, if one of the equipment grounding conductors is isolated from the ground screw, it must be counted separately, resulting in a total of 4 cubic inches for the equipment grounding conductors. When calculating the cubic inch volume occupied by devices within the box, it is essential to refer to the device markings or manufacturer's specifications. The NEC requires that each device, such as a switch or receptacle, be counted as 2 conductors based on the largest conductor connected to the device. For example, if a switch is connected to 14 AWG conductors, it is counted as 214 AWG conductors, or 4 cubic inches. If the switch is connected to 12 AWG conductors, it is counted as 212 AWG conductors, or 4.5 cubic inches. For devices that have multiple conductors connected to them, such as a multi-wire branch circuit receptacle, the device is counted based on the total number of conductors connected to it. For example, a multi-wire branch circuit receptacle with 414 AWG conductors connected to it is counted as 414 AWG conductors, or 8 cubic inches. In addition to conductor and device fill, the NEC also requires that certain allowances be made for other items within the box, such as cable clamps, support fittings, and fixture studs. Cable clamps that are internal to the box are counted as 1 conductor based on the largest conductor entering the box through the clamp. For example, if a 12E-2 cable enters the box through an internal cable clamp, the clamp is counted as 112 AWG conductor, or 2.25 cubic inches. Support fittings, such as those used to support luminaires or ceiling fans, are counted based on their volume as marked on the fitting. If the fitting is not marked with its volume, it is counted as the volume occupied by the largest conductor connected to it. Fixture studs, which are used to support luminaires directly from the box, are counted as 1 conductor based on the largest conductor connected to the luminaire. When selecting an electrical box, it is important to consider the type of box, its material, and its listed volume. Electrical boxes are available in various types, including metallic boxes, non-metallic boxes, and concrete boxes. Metallic boxes are typically made of steel or aluminum and are suitable for use in a wide range of applications. Non-metallic boxes are typically made of plastic and are suitable for use in dry locations where grounding is not required. Concrete boxes are designed for use in concrete walls and ceilings and are typically made of steel or cast iron. The material of the box can affect its ability to dissipate heat and its resistance to corrosion. Metallic boxes are generally better at dissipating heat than non-metallic boxes, and steel boxes are more resistant to corrosion than aluminum boxes. The listed volume of the box is the maximum volume of conductors, devices, and fittings that the box is designed to accommodate. The listed volume is typically marked on the box and is expressed in cubic inches. It is important to select a box with a listed volume that is sufficient to accommodate all of the conductors, devices, and fittings that will be installed in the box. Overfilling an electrical box can lead to overheating, short circuits, and even fires. It is also a violation of the NEC. To avoid overfilling, it is always best to err on the side of caution and select a box with a larger listed volume than is strictly required. Here are some additional tips for calculating electrical box fill. Firstly, always consult the NEC for the most up-to-date requirements and interpretations. Secondly, use a box fill calculator to simplify the calculation process. There are many free box fill calculators available online and as mobile apps. Thirdly, when in doubt, consult with a qualified electrician or electrical inspector. It's important to remember that electrical work can be dangerous, and it is always best to leave it to the professionals. The NEC is updated every 3 years, so it is important to stay current with the latest requirements. The NEC is available for purchase from the National Fire Protection Association, or NFPA, and from various online retailers. Many local jurisdictions also adopt and enforce the NEC, so it is important to check with your local building department to determine which edition of the NEC is in effect in your area. Using a box fill calculator can help to ensure that you are calculating the box fill correctly and that you are selecting the appropriate size box. These calculators typically take into account all of the factors that affect box fill, such as the number and size of conductors, the number and type of devices, and the presence of any cable clamps or fittings. If you are unsure about how to calculate electrical box fill or how to select the appropriate size box, it is always best to consult with a qualified electrician or electrical inspector. They can help you to ensure that your electrical installation is safe and compliant with the NEC. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself from electrical shock. Always turn off the power to the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you are not comfortable working with electricity, it is best to leave it to the professionals. To further clarify the rules surrounding equipment grounding conductors, it's important to understand the nuances. While all equipment grounding conductors are generally counted as one, there are exceptions. If a grounding conductor enters the box but does not terminate within that box and simply passes through to another location, it still counts as one conductor for box fill calculations. This is because it occupies space within the box. However, if a grounding conductor is larger than the circuit conductors, its larger size must be used for the cubic inch calculation. For instance, if a circuit uses 14 AWG conductors but a 12 AWG grounding conductor is present, the grounding conductor's 2.25 cubic inch value is used instead of the 2 cubic inch value for 14 AWG. Another point to consider is the use of cable connectors. Some connectors, particularly those used with non-metallic sheath cable, are designed to be installed outside the box. In these cases, they do not contribute to the box fill calculation. However, if the connector is installed inside the box, it must be counted as one conductor based on the largest conductor that enters the box through the connector. Regarding devices, it's important to note that not all devices are counted as two conductors. Some devices, such as low-voltage controlled devices, may have a smaller volume and are permitted to be counted as less than two conductors, but that usually requires specific listing and markings by the manufacturer. Also, if a device such as a dimmer switch has heat sinks that extend outside the box, only the portion of the device that resides inside the box contributes to the box fill calculation. The NEC provides specific rules for calculating the volume occupied by these types of devices. In situations where multiple cables enter the box through a single cable clamp, each cable is counted separately for conductor count. However, the clamp itself is only counted once based on the largest conductor entering through that clamp. For example, if 240-2 cables enter through a single clamp, there are a total of 6 current carrying conductors plus 1 conductor for the clamp for a total of 7 conductors for box fill calculation purposes. When dealing with conduit bodies, such as LB fittings or pull boxes, the box fill rules are different than for standard electrical boxes. Conduit bodies are typically marked with a cubic inch capacity, and the number of conductors permitted in the conduit body is based on this capacity and the size of the conductors. The NEC provides specific tables for determining the maximum number of conductors permitted in conduit bodies. In addition to following the NEC requirements, it's always a good practice to leave some extra space in the box. This makes it easier to work with the conductors and devices, and it can also help to dissipate heat. A slightly larger box can often make the installation process easier and more professional looking. When retrofitting existing electrical boxes, it's important to carefully assess the existing wiring and devices to determine if the box is adequately sized. If the box is too small, it may be necessary to replace it with a larger box. This can be a challenging task, especially in older homes, but it's essential to ensure the safety and compliance of the electrical system. In some cases, it may be possible to use a box extender to increase the volume of an existing box. However, box extenders are not permitted in all situations, and it's important to check with your local electrical inspector to determine if they are allowed in your area. Another consideration is the type of wiring method used. Different wiring methods, such as non-metallic sheath cable, armored cable, and conduit, have different requirements for box fill. For example, non-metallic sheath cable requires more space than armored cable because the cable itself takes up more room in the box. Conduit, on the other hand, provides the most efficient use of space because the conductors are typically pulled through the conduit after the conduit is installed. When planning an electrical installation, it's always best to start with a detailed wiring diagram. This will help you to determine the number of conductors, devices, and fittings that will be required, and it will make it easier to calculate the box fill. A well-planned wiring diagram can also help to prevent errors and save time during the installation process. Also, using push-in connectors is generally discouraged. They also can increase the box fill required. Wire nuts are better to use and take up less room, but push-in connectors can be faster.